Next, we have Jim Breakall from Penn State University and also from Arecibo.
All set?
All set.
Okay, thank you. Do I need speech processing with this? Or? Yeah, more compression. I just wanted to say that our local radio club in State College, where Penn State's located, did the space station with the school there. And they did it in a big auditorium, and it was streamed on the internet, and it was really a great thing. So that is a good thing. And just to give a little competition, I think Ward mentioned about competition to Dave. Okay, I'm from Penn State, and the students who gave the talk, you might want to apply to Penn State as well. Okay, so it turns out that there's a thing in the university called First Year Freshman Seminar. And back when that started, it was about maybe around the year 2000 or so, that my department asked me, how would you like to teach a course for First Year Freshman Seminar, this new thing that all students have to take all across all universities in some area that might be of interest to their major. And they said, how would you like to teach one on ham radio? And I said, pinch me, you know. And so I've been teaching that every semester since about 2000, and we probably licensed over about 700 hams, believe it or not, with students at Penn State. Okay, today I'm going to talk more on engineering than science, because everybody knows good engineering is needed to do good science. And so we're going to talk about a little bit of history of something called ionospheric modification, and then especially at Arecibo. And I'm on sabbatical this year from the university, Penn State, and I just came back from Arecibo, where with my good colleague back there, Angel, who works at the Observatory. Okay, so at the Observatory, you probably see my name there, Breakall. It's sort of a strange name. It actually comes from Scotland, I was told, but I don't know why that name exists. But anyway, in Spanish, does anybody in here speak Spanish except for Angel? In Spanish, Breakall is like sort of break everything, and it's rompe todo. So when I go to the observatory, I'm known as Senor Rompe Todo. They even put that on the door of the office I was in. Okay, so Senor Rompe Todo. Okay. Actually, I'm a graduate at Case Western, got my PhD here a couple years ago, and 1983, I guess it is. Let's see the laser. Oh, okay, right there. And I owe a lot to several professors who, one is deceased and one is retired now. Professor Matthews, who I think Jim mentioned about having a link to Arecibo, and then Professor Bob Collin, who is a very famous antenna person. So I owe a lot to these guys. And my PhD was involved with Arecibo on what's called incoherent scatter radar, and doing the calibration and doing measurements of incoherent scatter radar using the big 1,000-foot dish at Arecibo. Well, ionospheric modification. I'm sure a lot of people in here can even speak a lot more to this. Some of you have probably done ionospheric modification, or what's known sometimes as heating, even though heating doesn't go across too good with the environmental types, okay? So they usually change the name to ionospheric modification. Anyway, there have been quite a few of these heaters in the world. I'm going to mention a few of the famous ones. And again, you can see some of the science that can be done here with ionospheric modification. One in particular was in Alaska called HARP. And the main purpose for HARP, it was really mainly came about with military funding and military interest. They wanted to generate ELF and VLF. I guess I should say VLF, not ULF there, but it could be ULF as well. And for communication to submarines. And what they were doing was there's these currents that flow, very sort of almost like direct current that flows, the auroral electrojet. And it's flowing through the ionospheric medium, which has conductivity. And if you could change that conductivity at some rate that would be at a very low frequency, you'd be basically modulating that current. And HAARP can do that with the extremely high power. And so it actually never really worked too good, to be honest, but they spent about $300 million of your dollars on it. So but there was a lot of other things done at HAARP as well. And they did create artificial aurora, things like that. Well, what ionospheric modification really is for, okay, there's a lot of conspiracy. You could read some of these things here. This one here, learn how HAARP ionospheric heating weapons interact with nanoparticles and chem clouds to be remotely controlled to go inside your body. Wow. And then, of course, everybody knows that ELF and HAARP can manipulate the weather and ocean waves and thinking and all kind of stuff, okay? Well, anybody that really knows, this is all garbage, okay? It's all conspiracy theories. And even Arecibo has had conspiracy theories that Angel could tell you about as well when they did heating. So it turns out the amount of energy that gets up to the ionosphere is probably no more. If you had a 100-watt light bulb up there, you'd probably have more field, okay? But you can do a lot of things in the plasma with a little bit of energy. And, of course, it's a lot of energy on the ground. Well, some famous ionospheric heating facilities. This one you probably know in Russia there, Sura. And the thing to look at is the ERP. And ERP is effective radiated power if you had an isotropic antenna, okay, an antenna that radiates uniformly all over. So they get about 80 to 190 megawatts. And you see the frequency, it's always at sort of low HF because that's where you can get the most heating. And you see there's usually a lot of dipoles, a lot of area, a lot of transmit power. That's like 750 kilowatts there. This one had 1.2 megawatts of transmit power. This is at Tromsø. Some of these aren't in existence anymore, okay, but these have been historically some of the ones. Look at the frequency and so forth. Again, the effective radiated power, 1.2 gigawatts with the 144 array and 300 megawatts with the 36. And high pass was one of the early ones, okay? High pass is in Alaska. It only had 8 dipoles, but it did have quite a bit of ground power, 8 150 kilowatt transmitters, and ERP about 70 megawatts. And you can do a lot of science with that. And then the big daddy of all, okay, is HAARP. And HAARP has 180 cross dipoles. It's a huge thing, okay? And it was built up in stages, $300 million, and so forth. 2.8 to 10, and it has 3.6 megawatts of power on the ground, and that can give an effective ERP of about 5 gigawatts at the highest gain, okay? So now you know why the conspiracy theories are out there, okay? Okay. Well, let's go to Arecibo now, talk about some of the heating facilities there, and then I'm going to talk about one that we designed and was built and is being used at Arecibo presently. Well, Arecibo came about with Dr. Bill Gordon. He was at Cornell and then Rice University. And, of course, he thought up the idea, not for heating so much, but it was incoherent scatter radar. And then they were originally just going to use a parabolic dish. And some of the astronomers said, you know, there's these things called spherical dishes that are being done now. And if you could have that, we could have a line of focus And since the sphere is symmetric, we could steer the beam instead of just having a beam going straight up. Luckily, they did that because Arecibo has done a lot of astronomy, planetary radar, things like that, and even Nobel Prize. Joe Taylor got the Nobel Prize for Einstein's theory from there. Okay, I have to tell a little story. I was down in Washington, D.C., taking the relatives around to all the museums. And so, you know, when you're walking around and everything, it was a hot summer day, you have to use the restroom. So we said, where can we go to use the restroom? The Smithsonian building, that red building, okay? So we went in there, and of course, it's just jammed with people. And the relatives were in the restroom. I'm just standing out there in the lobby, and all of a sudden, on a huge screen, comes Arecibo. And it was this clip here. And they actually zoomed in on the heating antenna that I designed for Arecibo. And I thought, wow, there's like thousands of people here. I'm the one that designed this. Let me see if this works here. This is just a little clip on Arecibo. There's a shot there of the heating array. Okay, it's actually, that's a little bit old because it isn't run by Cornell University anymore. It used to be run by Cornell for like 40-some years. It's now, and then it was transitioned to SRI and a consortium and a local university in Puerto Rico. And now it's being run by the University of Central Florida and a university in Puerto Rico. Just to clarify and correct that. Oh. Okay, so let's get into some of the past heating facilities at Arecibo. Of course, most of the stuff with Arecibo is used for higher frequencies, okay, up to even the gigahertz range, UHF, VHF, gigahertz. But anyway, for HF, the first antenna was a crossed log periodic, and then I'll talk a little bit about that. And then there was a big heating array that was off-site, and I'll talk a little bit about that and why those don't exist anymore. Okay, this is a log periodic. If you're familiar with this kind of antenna, it has a very wide bandwidth. It actually covered 3 to 10 megahertz, and it sat up there in the platform and fed the dish. The problem is it was made out of wires, and there were points at the end, a zigzag arrangement. And so that antenna had a lot of arcing, and so it really didn't work too good. It did have reasonable, ERP, but not really that good. There's some more pictures of it right there, and they could actually fold this up like an umbrella and store it against the tower there. Okay, am I out of time already? Almost. So I'll have to really speed up here. The second heating facility, and I worked on this also, was a big array of 32 log periodics. Here's what they look like here, and here's an actual photograph. And this had pretty much a constant gain over frequency. There I am right there. Okay. I'm a grad student. The problem was, because the spacing stayed constant in physical spacing and wavelengths, it got bigger as you went higher in frequency, and you got these things called grating lobes. So even though the gain always stayed constant, you had these other fingers sticking out. Well, anyway, that antenna was destroyed by Hurricane Georges in 1989, and so the observatory didn't want to build it on an off-site, so they said, can we build this at the observatory? And so the cost was about $2.5 million, and these were the sponsors for it. And then they got a lot of equipment, transmitters, power supplies, and coax, heliacs from a military project, the over-the-horizon radar that had been decommissioned. Anyway, this was the first concept, actually putting up a Yagi. I think the students mentioned about they built a Yagi. That's what this is. This is a Yagi, a dual band Yagi, okay? Pretty much like, you have a tri-band antenna. This was a dual band. And this was what it looked like, but you had to have these balls at the end, and this is 8-inch tubing because we have a lot of power we were going to put into that. And so that's to prevent the corona and arcing. This was the concept. It would be hung from the dish. And at Penn State, we actually built some scale models using beach balls and sono tubes. We covered those with chicken wire and aluminum foil. And then we decided that we need, that wasn't going to work so good, getting the energy up to that. And so we said, let's put the antenna down at the bottom of the dish, an array, and then feed a reflector called a Cassegrain system. And so that's what we did there, and this is what the model looked like. And then if you look at the currents that are flowing in this thing, I guess that isn't working. Anyway, the currents would go around, okay, with circular polarization, but there wasn't much current in these tips here. You can see that. Most of the current is right there, so we said, let's just cut off those triangle pieces, and this is the way it came out. And there's what the model looked like, final design. And it has a gain about 22 and 25, and an ERP, it is getting up there, 200 megawatts. Okay. I'll just show a couple quick pictures of it here. There's under construction. There's the final. And there's close-ups, okay? There's how you hooked up your wire to the element. So you get an idea of how big. This is the feed point of that. Oh, I should mention this. These are all the coax. It's 3-inch heliacs that feeds that, okay? And there's the mesh, or we call it the mess, okay? Look at that. There it is up, okay? So it looks pretty neat when it's up. There's the transmitters, and be pretty good for a 6-band contest station, okay? 600 kilowatt. And these are the tubes. It goes like 10 kilowatts, 25 kilowatts, 150 kilowatts. Okay. I'll just go through this quickly because I know I'm out of time, I think, pretty close here. This is a dummy load. You don't find that kind in the ham say. These are all the heliaxes running out there. And the transmitter is water cooled. That's how they do the cooling. 100 kilowatts. I like that picture. Now, just real quick, I'll show some old pictures. There's me on the original, and this is Bill Gordon right here. And this is Bill Gordon at the 40th anniversary with some of my students down there. And then this is me again with the Puerto Rican mafia, okay? here I am with the John Denver look from Arecibo, from a 100-foot dish that I worked on at Arecibo. And then there's been many famous hams at Arecibo as well, including Sam Harris. He was the first moon bouncer. And then we decided to do moon bounce again with Angel back there and Joe Taylor and some other hams. And this was back in 1964, and this is 2010. Okay. KP4AOs. Did anybody work KP4AO in here? Yeah? Okay, tried it. Okay, and then that's my, we say my brother from another mother, okay, Angel, he's sitting back there. And I have some pamphlets that Angel brought on Arecibo, and as well as Angel would be happy to talk about how they're having a new program. It's basically you can pay to observe, pay for crowdsource funding and so forth. And so Angel would be the guy to talk to if you want to talk more about that, hear more about that.
And they also rent it out as a contest station too, right?
What's that?
You can also rent it for CQ Worldwide, right?
Oh, yeah, with those transmitters.
Yeah.
Yeah. Thank you very much.